Hello gems! Welcome to a series. In this video, we are going to discuss previous year BITSAT questions from the chapter of current electricity. Now current electricity has a very good weightage at BITSAT. Okay, so you wouldn't want to miss this video. Now as we begin with this video, keep all your worries, all your distractions aside. For the next hour or two, it's just me and you and physics, of course. So let's begin with today's class. Question 1 over here from the super easy category from 2008. In this question, potentiometer measures the potential difference accurately as it. Okay, so you have to select one correct option among this. In fact, it is a board level question. You can surely give it a try. Okay, you should be ready with your answer in 3, 2, 1. The correct answer over here is option A. Okay, potentiometer measures the potential accurately because it measures the potential in an open circuit. Now what do we mean by open circuit? Open circuit is a circuit in which current is zero. Okay, in which there is no current or the current is zero. You can clearly see the advantage of this. You can see that the voltage drop across your internal resistance, which is given as IR. This is voltage drop across internal resistance. Okay, I is current, R is the internal resistance. You can see that this term will be zero, right? Because I is 0, this term will be 0. So you can see that there is no voltage drop across your internal resistance, which means that potentiometer can measure the EMF of the cell accurately. Okay, to say it in the language of NCERT says that potentiometer is more accurate in measuring the potential difference because it draws no current from the cell. Again, the same thing, right? Draws no current, open circuit, current is 0. Okay, I hope that thing is clear. Let's move to the next question now. So question 2 over here, again from the super easy category from 2014 this time. Okay, so in this question you are given two wires X and Y made from the same material. It is given that diameter of wire X is half the diameter of wire Y. The length of wire X is half the length of wire Y. Okay, you are supposed to compute this ratio Rx by Ry. Rx is the resistance of X wire, Ry is the resistance of wire Y. Okay, so it is quite simple. You can see that Rx by Ry will be given as, here in place of Rx, in place of R you can write rho L by A, right? Resistance is given as rho L by A. So in place of this Rx we can write rho Lx, length of the wire X, divided by area of the wire, right? And in place of Ry we can write rho Ly, and Ay will go on top, right? Rho Ly by Ay, that Ay will go on top. Okay, this row and this row will get cancelled. You can see that both the wires are made from the same material, which means both of them have the same resistivity. Okay, so you can club these terms together, Lx by Ly and Ay by Ax. Now in place of Ay and Ax you can place it in terms of radius, right? Pi r square. In place of area you can write it as pi ry square, and here pi rx square, right? So here you can see Lx by Ly. Lx by Ly is half, and here pi and pi will get cancelled, and Ry by Rx you can write it as Ry by Rx the whole square, right? You can write it that way. So Ry by Rx will be same as dx by dy, right? Or will it be double or will it be half? It will be same. Okay, if you see in place of this dx you can write 2rx, right? 2 times the radius of x equals diameter of x, and here also 2 will come, 2 times the radius of y will be diameter of y. Okay, so this and this will get cancelled. So you can see that the radius basically will have the same ratio as that of the diameter. Okay, getting my point? So okay, so here Ry by Rx will be same as dy by dx. Okay, so that is what I mean. So Ry by Rx will be same as dy by dx, which is 2. Okay, so cross this, dy by dx, it will be equal to 2. Okay, so dy by dx the whole square, right? Ry by Rx the whole square. So here you can see it will be 4 by 2, or it's simply 2:1, right? So the correct option over here is option C. 2:1 is the correct ratio over here. Let's move to the next question. So question 3 over here, again a very simple question. In this question you are told that for a wire of radius r, the drift velocity is Vd. Okay, you are supposed to tell what will be the drift velocity for a wire of radius 2r. Okay, it is also told that the current in both the wires is kept same. Okay, so the relation that we are going to use over here is I equals NE AVD. Okay, you can see that N and E will not change in this case. Okay, number of charge carriers and the charge on the electron will not change in this case. The only thing changing over here is the area, because the radius is changing, and also the drift velocity will change. Okay, so in case 1 we can write it as NE. In place of area we can write it as pi r square, right, and the drift velocity is Vd. Okay, so again we'll use I equals NEAVD for the second case. In this case you can note that NE will remain same, only the area will change. Area will be pi into 2r square, right, pi 2r square. Okay, because the radius is doubled now, and drift velocity will change. Let us call it Vd dash. Okay, so now you can see that it is told in the question that I is kept same, right? So you can just equate these values and hopefully you'll have your answer. You can see that here Ne pi r square, right? Ne pi r square will get cancelled and you'll be left with 4 Vd dash equals Vd. Okay, Ne pi r square, that will get cancelled. Here 4 Vd dash equals Vd. So Vd dash, which is the drift velocity in this case, is given as Vd by 4, 1/4 of the drift velocity in this wire, right? So option D, Vd by 4, is the correct choice over here. With this question we wind up with the super easy category. Let's move to the easy category now. Question 4 over here. This question is based on temperature dependence of resistance. Okay, so in this question you are told that the resistance of a resistor at 20 degrees Celsius is 20 ohms. The resistance at 500 degrees Celsius is 60 ohms. Okay, so you are supposed to find a temperature at which the resistance of that resistor is 25 ohms. Okay, the actual approach is quite straightforward. You can see that you will find the value of alpha from this data, right? The alpha, the temperature coefficient from this data, and that alpha you'll use over here, and then you'll find the temperature. Okay, so let's apply that approach. So we can write R500 applying the temperature dependence equation over here. So R at 500 equals R at 20 into 1 plus alpha into delta T, right? This is the temperature dependence equation which we are using. So R at 500 is 60 ohms, R at 20 is 20 ohms. This is 1 plus alpha which we have to find. So alpha into delta T. What is the change in temperature? It is from 500 to 20, right? Sorry, 20 to 500. Okay, so it is 500 minus 20, right? So that will be 480 change in temperature. So 20 3s are 60, 3, so you have 3 equals 1 plus alpha into 480, so that will be 2. This 1 will come to the other side and divide by 480. 1, 3 minus 1, 2, divide by 480 will give you alpha, right? So alpha is 1 by 240. So you got the value of alpha. We'll use it again in this equation now. Again R at T, again we'll use the temperature dependence of resistance. Here we'll use R at T equals R at 20 into 1 plus alpha into delta T, right? Again the same equation. Here we have just changed because we want to take it to the temperature T. Okay, so here we know that, I'll just clear this up. Okay, here we know that resistance at T is 25, resistance at 20 is 20 into 1 plus alpha. Alpha is 1 by 240 into delta T. Now you can see that the temperature is changed from 20 to T, right? 20 to T. So the difference, temperature difference over here is T minus 20. Just like in the previous case, it was 520 to 500. So the temperature difference was 500 minus 20, 480. Okay, so here also T minus 20. Okay, now let's solve this. 5 5s are 5 4s are. Okay, so 5, I'll take this in. So 4 into 4 into, I can cancel this 4 and 240. So I'll get T minus 20 divided by 4 6 are, right? So 6 are, and here you'll have 1, 5 minus 1, 5 minus 4, 1. Okay, T minus 20, the 60 will come over here. Okay, just quick maths. So this will give you T as 80. Okay, so the temperature over here should be 80. So for the resistance to have a value of 25 ohms, the temperature should be 80 degrees Celsius. Okay, I hope the approach is clear. We just use the equation of temperature dependence of resistance. That's all what we did over here. Okay, over to the next question. So question 5 over here from 2016. In this question, you are supposed to find the effective temperature coefficient of the system. Okay, so in the system, you have two resistors, each with resistance R0. The temperature coefficients are respectively alpha 1 and alpha 2. Okay, so the question remains the same. Find the effective alpha, which is the effective temperature coefficient. Okay, if you think about it, it is not that difficult. You can see that both the resistors are connected in series, so you just have to account for the effective temperature coefficient in series combination, right? So we can write it as the equivalent resistance. In this case will be R1 plus R2, right? R1 plus R2. You can see that both of them are in series, right? So we can easily write this R equivalent will be 2R0, right? R0 plus R0, that will be 2R0. But here we have to write the temperature dependent equation, right? So along with that 2R0, we have for the entire system we are writing. Keep that in mind. So 2R0 into 1 plus alpha into delta T. Okay, this is for the entire system. So this alpha is effective. Okay, we are considering this system. So 2R0, 1 plus alpha into delta T. Okay, in place of that R equivalent. Now R1 will individually write it as a temperature dependent equation. Okay, so here we'll have R1 as R0 into 1 plus alpha into delta T. Okay, so we are considering the temperature change as delta T. So yeah, R2 will be again R0, and here we'll have alpha 1, right? For R1 it's alpha 1, for R2 it's alpha 2. Okay, so R0 into 1 plus alpha 2 into delta T, right? That is R1 plus R2. Okay, we are writing the temperature dependent equation. Okay, keep that in mind. So you can see that this 2R0 will get cancelled. Okay, first of all, open that bracket. 2R0 plus 2R0 alpha effective into delta T will give us here R0 plus R0. So you'll have 2R0 again, right? R0 plus R0, 2R0, and here you'll have R0 into alpha. Here I can take R0 common. Okay, so I'll write R0 into, what am I doing? I'm taking that R0 common from the second term. Okay, from the second term of each of this. So R0 is common. Here you'll have alpha 1 into delta T plus alpha 2 into delta T. Okay, so you can see that this and this will get cancelled. 2R0 will get cancelled, and here we have 2R0. What is left? 2R0 alpha effective into delta T equals, here delta T also can be taken common. So here R0 into delta T, we have alpha 1 plus alpha 2, right? So again you can see R0 will get cancelled, delta T will also get cancelled. You can see that alpha effective will be alpha 1 plus alpha 2 by 2, right? Alpha 1 plus alpha 2 by 2. Okay, so we just use the logic of series combination over here. We individually wrote the temperature dependent equation, we solved it, and we hopefully reached our destination. Okay, so The answer over here is alpha 1 plus alpha 2 divided by 2. Over to the next question. So question 6 over here from 2017. In this question, it is given that the power dissipated across this 5 ohm resistor is 10 calories per ohm. This is the power dissipated across the 5 ohm resistance. Okay, and you are asked for the power dissipated across the 4 ohm resistance P2. Okay, so one straightforward approach of doing this question is, first you can find the voltage across this points. Right, you know the power, you can just use V square by R and you can find the voltage across these 2 points, right? So the same voltage will be across these 2 points over here because they are in parallel, right? So same voltage drop over here. Now you can split that voltage among this and this, right? Among the 6 ohm resistance and the 4 ohm resistance. Suppose the voltage drop across the 4 ohm resistance is V1. Okay, now you'll know the value of V1, so you can use V1 square by R, P is equal to V1 square by R, and that will give you the value of power dissipated across the 4 ohm resistance. But that is a lengthy approach over there. Okay, so we'll use our basic knowledge over here. We'll use the equations of power. So we'll use P1 is equal to I1 square R1 and P2 is equal to I2 square R2. Okay, using this we'll solve this question. Okay, so now we will take the ratio over here, and P1 by P2 will be I1 by I2. Now P1 represents power dissipated across the 5 ohm resistance. R1 will be 5 ohm in this case, and I1 is the current passing through it. And here in this case P2 represents power dissipated across the 4 ohm resistance. R2 is 4 ohms over here, and I2 is the current passing through it. Okay, so I1 by I2 the whole square into R1 by R2. Okay, so you can see that I1 by I2. I'll tell you how to find this ratio. We'll come to this one now. R1 by R2. R1 is 5, R2 is 4. 5 by 4, right? 5 by 4 over here, and P1 is 10, P2 we have to find. Now how to find this ratio I1 by I2? You can see that these two are in series combination. So here in this branch the equivalent resistance is 10 ohms, right? Equivalent over here is 10 ohms, and here we have 5 ohms, right? So suppose the current incoming was 3I. Okay, the incoming current was 3I. You can see that it will split as 2I and I over here, right? Because the resistance is less over here, it will split as 2I over here, and there it will be I. You can see that 2 into 5, 10I, 2I into 5, it is 10I, and here also 10I, right? Equivalent resistance into I. Okay, so potential difference same at both the points. Okay, so that logic we used, we split the current. You can see that I1 current passing through the 5 ohm resistance, it is 2I, and I2 is I. Okay. Now even if you didn't get this current splitting logic, I can convince you about this in one more way. Okay, I can write the potential difference across this point will be same as the potential difference over here. Let's bring it to the original state. Here it is I1, here it is I2. Okay, so I'm using the logic, potential difference across here, across these 2 points is same as the potential difference over here. So we can write 5 into I1, which is the potential difference across these points, equals 10 into I2, right? Here it will be 4 into I2 plus 6 into I2. Okay, so that is 10 into I2, right? So you can easily see that I1 by I2 is 5 by 10, which is 10 by 5, which is 2. Here also we get the same thing, right? This I and I will get cancelled and we have the same thing. Okay, so you can see that this will be 2 square 4, and it will cancel with this 4, right? And you'll have P2 as 10 by 5, P2 as 10 by 5. Okay, so that will be 2 calories per second. Option B is the correct choice over here. Okay, I hope the approach is clear. Over to the next question. So question 7 over here from 2010. In this question, it is given that power dissipated in this circuit is 30 watt. You are supposed to find the value of this unknown resistance. Okay, a very simple question. we will write power as V square by RE. Okay, if you are curious why I am using this format, because here the combination is parallel. Okay, the V is constant, it is 10 in both the case, right? So I am using V square by the R equivalent. I am using V square by R format over here. Okay, so power it is given as 30, and here voltage will be 10, 10 square 100. R equivalent, that will be product upon sum, right? These two are in parallel combination, so product upon sum. So 5R product, 5 into R upon R plus 5, so that will go on top, 5 into R divided by R plus 5, right? So we get this. So 5 will cancel 100 in 20, 5 2s are, yeah, and this will get cancelled. So we have 3R is equal to 2R plus 10. So you can see that R is equal to 10 ohms. Okay, so R is equal to 10 ohms. Option C is the correct choice over here. No wasting time over here. Let's move to the next question. So question 8 over here. In this question, you are given a circuit. You are supposed to solve this circuit and tick the correct option among this. Okay, you can surely pause this video now and give this question a humble try. I will do it in 3, 2, 1. Okay, first of all, I will find the equivalent resistance in this circuit. So I'll start from this back end. So I'll start from here. So you can see that this 2 ohm, 4 ohms and 2 ohm are in series combination, right? They are connected end to end with each other, or you can see that the current passing through all three of them is the same, right? So you can see that all three of them are in series combination. In series combination, just add the resistances. So that will give you 2 ohms plus 4 ohms, 6 ohms and plus 2 ohms, that will be 8 ohms. Now this 8 ohms and this 8 ohms will be in parallel combination, right? This 8 ohms and this 8 ohms will be in parallel combination. Okay, follow me up. I'm going to do this verbally. So here we'll have 4 ohms. Okay, R and R in parallel gives R by 2. Remember that. Rote army. Okay, let's wrote the general results over here. So R and R in parallel will give us R by 2. So 8 and 8 in parallel will give us 4 ohms. Okay, so let's draw the circuit over here. So here we'll have the 9-volt battery. So now in place of this, we have a 4 ohm resistance, right? Because this is 8 and this is 8, right? 8 and 8 in parallel gives us 4. Okay, so that is the reduced form of the circuit that we have now. Okay, so let's solve it further now. You can again see the same pattern, 4 to 2 in series and in parallel with 8 ohms, right? So this is 8 ohms and in parallel with 8 ohms. R and R in parallel, rote army, it's R by 2, it's 4. Okay, so here we'll have the equivalent circuit. So here we have 9 volts battery, so finally the circuit has reduced to this. You can see that this becomes 4 ohms, right? 8 and 8 in parallel gives us 4 ohms. So now we can find the current in the circuit. Now it's a very easy job. You can simply write I is equal to V by R, right? Here you can see that all three of them are in series, connected end to end. So V by R, V is 9 over here and in series, so just add this resistances, 4 plus 3 7, 7 plus 2 9, that gives us 9. So 9 by 9, that will be 1 ampere. Okay, so 1 ampere current is starting from our battery. Okay, so now you can see that the current through this 3 ampere resistor is not 0.5 ampere, neither it's 0.25, it's 1 ampere, right? So option A and option B are incorrect. Let's check for option C and D. Now remember that this 4 ohm resistance which is mentioned in the question is not this one. Okay, it is this one, because the question asked us to solve this circuit, right? We reduced it to this form. So it is not this 4 ohms that is mentioned in the question. This 4 ohms is over here. Okay, so we have to find the current through that one. Okay, so we'll come over here now. Here you can see that 1 ampere will come over here at this junction, right? 1 ampere current will come to this junction. Now it has two choices, right? So from either it can flow in this branch and this branch. Okay, so how much current will go in this branch and how much will go in this branch? You can see that here it's 8 ohms and here also it's 8 ohms, right? 2 plus 4 plus 2, that is 8 ohms, right? So you can see that the current will split into half, right? Half current will go through this 8 ohms and half current will go through that 8 ohms. So 0.5 amperes will go through this branch and 0.5 amperes will go through this branch. Okay, should I show it over here? Okay, I'll show it over here. So that is 0.5 amperes. Okay, now let's draw it. Let's bring it again over here because we want the current through this 4 ohm resistance. Okay, so now we have 0.5 amperes over here in this branch and 0.5 amperes over here, right? Now in place of that 4 ohm resistance, we again come back to the previous step. Okay, so here we had 1 amperes. Okay, anyways, we are not worried about that. Let's come over here. You can again see a junction over here. Now we have 0.5 amperes and again you can see that in this branch we have 8 ohms and in this branch we have 4 plus 2 plus 2, again 8. Okay, so 8 and 8. So current will again split into halves. Okay, it will again split into half and here we'll have 0.25 ampere. Okay, and here the current in this branch it will be 0.25 amperes. Okay, so the current passing through the 4 ohm resistance is nothing but 0.25 amperes. Okay, so option D is the correct choice over here. Okay, I'll just summarize the steps. First of all, we found the equivalent resistance. Then we found the current in the circuit, the current which is drawn from the battery, it was 1 ampere. Then we moved back, we reversed our step, it was a rewind then. Okay, just to come to this circuit, splitting the current into the branches and finding the current in each branch. Okay, so then we came to know that the current in the 4 ohm resistance is 0.25 amperes. Okay, so that is how we did this question. Over to the next question. Question 9 over here. Here you are supposed to find the current through this 45 ohm resistance. Okay, so first of all we need to solve this circuit, find the equivalent resistance. Using the equivalent resistance we can find the current which is drawn through the cell. Okay, and then we can split the current again and find the current through the 45 ohm resistance, just like we did in the previous case. Okay, so let's find the equivalent resistance first. Here you can see that we'll start from here. Here you can see 50 ohms and 50 ohms are in series combination, right, connected end to end. So yeah, if you see same current passes through both, right, so they are in series combination, this 50 ohms and 50 ohms in series combination. So just add them, 50 plus 50, 100, and now this 100, this 100 and this 100 are in parallel combination, right, connected across the same potential difference. Okay, so this 50 ohms and this 100 ohms and this 100 ohms in parallel makes it 50. 100 and 100 in parallel makes it 50. Okay, just like R and R in parallel makes it R by 2. So 100 and 100 in parallel makes it 50. So we simplified this part and we have 50 over here. I hope you were able to follow me up. Okay, so we have 50 ohms over there. Let's simplify this part now. Here you can see this 100 ohms and 100 ohms in series combination. Same current passes through both. So 100 and 100 in series makes it 200, 250 in parallel. So R and 4R, that won't work now. So let's use product upon sum, right? So 250 in parallel, right? So 200 into 50 divided by their sum. So product upon sum. Okay, so 50, 5s are 255, 4s are 20, 0. So 40 ohms. Okay, so here we have 40 ohms. Okay, and other things have not changed. Here we still have 90 ohms and the circuit above remains the same. Okay, here you can see that this 40 and 50 are in series combination. If there is a current from here, same current will pass through both, right? So they are in series combination. Okay, this 40 and 50 are in series combination, so just add them. 40 plus 50, 90, 90 and 90 again in parallel combination, right? connected across the same potential drop. So 90 and 90 in parallel makes it 90 by 2, right? R and R in parallel makes it R by 2. Okay, so here we'll have 90 by 2, which is 45. Okay, we can replace this now by 45. Okay, so we have simplified this part now. So here we'll have 45, here again 45. So finally we have this circuit. After simplification we get this. Okay, so here 180 volt battery and this circuit. After simplifying, after reducing this whole circuit, we get that. Okay, so now you can easily see the equivalent resistance will be, now you can see that this two 45 and 45 again in series and in parallel with that 90, right? 45 and 45, same current will pass through both, and this both of them are in parallel combination with this 90. Okay, connected across the same potential. So 45 plus 45, 90, 90 and 90 in parallel again, so that makes it 45, right? R and R by R and R by 2. Okay, so here we have 45 and here we have 180 volts battery. So let's find the current through the circuit. The current will be given as V by R. V is 180, R is 45. Okay, here we are substituting R equivalent. Okay, so the current through the battery, let's do some math over here. Let's multiply it by 2. Okay, multiply numerator and denominator by 2, so that makes it 45 into 2, 90, 90 2s are 180, 2 2s are 4 amperes. Big brains. Okay, so here we have 4 amperes coming out from the battery. Now we have to just split that 4 amperes in the circuit and see what is the current in the 45 ohm resistance. Okay, so let's do that. So let's come over here. So 4 amperes current is coming from the battery. Here you can see that it has two choices, right? One is this branch, right? One is this branch and one is this branch. Okay, you can see that both the branches have same resistance, 90 over here and 45 plus 45, 90 over there. So the current will just split into half. Okay, because the resistances in the two branches are equal, current will just split into half. Okay, equal preference over there. So 2 ampere will flow through this branch and 2 ampere will flow through this branch. So you can see that you can see from here that current through the 45 ohm resistance is 2 amperes. Okay, so option B, 2 amperes is the correct choice over here. This was very similar to the previous question. Now let's move to the next question. So question 10 over here, circuits. So again in this question we have a circuit. We are supposed to find the equivalent resistance between A and B. Okay, this might seem straightforward, but it is a question from the easy moderate category. Okay, so pull up your socks and try this one out. Okay, so here you are supposed to note a very amazing thing. The thing is, whenever you cannot determine whether two resistances or two or more resistances are in series or parallel combination, you should look out for some other things. And what are those some other things? Among them is a balanced Wheatstone network. Okay, so here you can see in fact a balanced Wheatstone network. Here I know there are 8 resistances instead of 4, like in a usual Wheatstone network, but here you can see in fact a balanced Wheatstone network. Okay, let us see how. Here you can see that 5 by 10 is equal to 10 by 20, right? 5 by 10 is half, 10 by 20 is also half. Okay, so whatever the potential is over here, suppose the potential over here is x, so the potential over here will be x, right? The potential at these 2 points will be the same. Okay, it's a balanced Wheatstone network, which means no current flows through this resistor. That resistor is useless. Okay, so we can remove this. Okay, no current flows through this branch. Now again you can see that this is a balanced Wheatstone network. Now you can see 15 and 30 over here, right? So 15 by 30 and here also 15 by 30, right? This is 15 in series combination, here also series combination, so 30. So 15 by 30, 15 by 30. Okay, so R1 by R2 is equal to R3 by R4. So again a Wheatstone network. So again potential over here Y is equal to potential over here Y. Okay, so no current flows through this branch. This resistor is useless. Now look at the combination. This is so simple, right? These 3 are in series combination, this 3 in series combination, and in together they are in parallel combination. Okay, so series combination, add this 3. So 15 plus 5, 20, 20, 30, 30, and here we'll have 30, 20, 50, 50, 10, 60. So we have over here, we have over there 30 ohms and 60 ohms over here. Now you can use product upon sum and that will give you your answer. Okay, so 30 into 60 divided by 30 plus 60, that will give you your answer. Anyways, I wish to mention a trick over here. I don't know if I mentioned this trick earlier in this video because I am just filming it on another day. So new hairstyle, yeah, I don't know what happened previously in the video. So yeah, the trick is if you have R and 2R in parallel, okay, if you have R and 2R in parallel, the equivalent will be 2R by 3. 2R by 3. Okay, so you can see that here we have 30 and 60 in parallel. You can remember also this way that R and 2R in parallel, the equivalent will be R big by 3. Okay, R and 2R in parallel, the equivalent will be R big, which is 60 divided by 3. Okay, so 60 by 3, that gives you 20. This is used in case when the second resistance is twice of the first one and they are in parallel combination. Okay, so the answer over here is option C, 60. Option C, 20 ohms is the correct answer over here. Okay, so this is in fact a very good result for the rote army to remember. Now rote army, if you see, is a very good concept, right? You remember general results that help you speed up your calculation. So it is a very good concept. If you see, BITSAT is all about speed and accuracy, right? And this is also a definition of speed. Speed is not just doing it quick, speed is also about skipping the steps. Okay, over to the next question. So question 11 over here from 2018. In this question, you are supposed to find the reading on this voltmeter. Okay, so basically we are supposed to find the potential drop over here across A and B. Okay, because that is what your voltmeter is reading, right? So it's the potential difference across these 2 points A and B, VA minus VB or VB minus VA. Okay, potential difference. So first of all, let us find out the current in the circuit. So, so that we can find the potential drop across this resistor, right? I into R, I into that R. So that will give us the potential drop across the resistor which we want. Okay, so let's find the current in the circuit first. Okay, so you can see that this current will come to this junction, and tell me this in the comment section now. Will the current split into two halves or split in some ratio and go in this branch and this branch, or will it go just in this branch or just in this branch? Okay, tell me that in comment section. Tell me the time, mention the time, and tell me whether the current will flow in this branch, this branch, this branch only, this branch only, or will it split in some ratio. Okay, the correct answer over here, I hope you have commented down there. Okay, so the correct answer over here is current will move only in the above branch, only in this loop. Let's name it A, B, C, D. Okay, so the current will move only in this branch. Okay, because voltmeter has infinite resistance. Okay, an ideal voltmeter has infinite resistance. So whenever the current reaches that junction, it will be like, yeah, god damn it, so much resistance, I am not moving that path. Okay, so basically it will move in this loop. Okay, A, D, C, B. Okay, so it won't go in that voltmeter branch. Okay, basically voltmeter, an ideal voltmeter, does not draw any current. Okay, so let's find out the potential drop in this case. No, first let us find out the current, right? So current will be given by, now you can choose this loop, apply Kirchhoff's law, but it is very simple. If you see, it is based on combination of cells, right? Here I can see that those two cells are in series or in parallel. Series, see, so the same current is passing through both. Okay, same current is passing through this loop, right? So this cell and this cell are in series. Positive is connected to positive, which means it is opposing. Okay, so if you don't know about this logic, you can use Kirchhoff law in that loop and you can find the current. Okay, I have no issues regarding that, just that your time will be wasted. So here I know it is opposing, so I'll say 15 minus 10. Okay, 15 minus 10. V net, first of all, we can write it as V net by R equivalent. Okay, V net by R equivalent. And these two resistances are in series, right? Of course, because same current is passing through both. Okay, don't let your eyes blind you. Don't believe your eyes first of all, because only look out for current. Okay, don't see the orientation of the resistances. Look out for current. If current is same in both the resistances, it means that they are in series combination. Okay, so here the equivalent resistance will be 1.6 ohms. Okay, so 15 minus 10, that will give you 5, and 1.6, this many amperes. Okay, so this is the current in this loop. Let's find the voltage. How will we find the voltage? We'll just choose the path A, B. Okay, then apply Kirchhoff's law over here. So we'll move from A to B. Okay, from A to B we'll move. So from A to B. So here we'll go from positive to negative. First of all, potential at A. Okay, here from positive we go to the negative terminal. So minus 15, right? Applying Kirchhoff's law, KVL over here. So positive to negative, minus 15, potential drop. Now we are moving opposite in the direction of the current, right? Current is in this direction, but we are moving from A to B. So here we are in the opposite direction to the current. So it will be plus IR, potential gain opposite to the current, right? So I we already know the value. I is 5 divided by 1.6 into R, that is 0.6. Okay, and that will give us the potential at B. Okay, so we just selected this path and applied KVL. So we are now supposed to find VA minus VB or VB minus VA. Okay, so let's find VA minus VB. That will be positive, right? Current flows from higher potential to lower potential. So VA minus VB, that will be positive. So 15 minus, here you can see here it's 8 by 3, right? Here we'll get 3 za and 8 za, so 8, so 3 by 8. Okay, so again 15 by 8. 15 minus 15 by 8, I can take 15 common, and 1 minus 1 by 8, 1 minus 1 by 8, that will be 7 by 8. And when you calculate this, the correct answer that you will get is around 13.125. Okay, 13.125 volts, and you can approximate it to option C. So option C, 13.1, is the correct choice over here. Okay, we just applied Kirchhoff's law over here. First of all, we found out the current. If you're not comfortable finding out current this way, you can go by the Kirchhoff's law. Okay, so anyways, 13.1 is the correct answer. No wasting time over here. Over to the next question. So question 12 over here. In this question, you are supposed to find the current through this 2 ohm resistor. Yeah, that is the question. You are also given that the voltage drop across A and B, the potential difference between A and B is 16 volts. Okay, you can basically imagine that by connecting this 2 to the 2 terminals of a 16 volt battery. Okay, so let's imagine the potential over here is 16 and the potential over here is 0. Okay, you can choose any two random numbers, keeping in mind that the potential difference, the difference between the two numbers, should be 16. You can choose 0 and minus 16 over here, 16 and 0, anything you can do. Basically, the difference between the 2 points should be 16. Okay, so let's take current from here. So you can see that this question exclusively includes, wow, the usage of your Kirchhoff's law. Okay, KVL and KCL. Okay, so let's take current moving from higher potential to lower potential. Here at the junction, let's split the current into I1 and I2. So basically you can see that we are supposed to find this I2, right? Current through the 2 ohm resistor. Okay, so we are supposed to find the value of that I2. Now again, I1 and I2 will meet to form I is equal to I1 plus I2, I1 plus I2 is equal to I. Okay, so this is a 3 volt battery. Okay, now let's choose a loop, and we'll also choose a path. Let's choose this path first, A to B. Okay, you can see two variables over there, I1 and I2. So we have to choose two paths or two loops over here. So here we'll choose one path, this A to B, and this loop over here. Okay, so let's write the equation in moving from A to B. So VA, so potential at A, and here we are in the direction of current, which means minus 4 I into R, right? I into R in the direction means minus. Okay, Now let's come to this. We are moving along the straight line. Okay, now we will move from positive terminal to negative terminal. Drop in potential -9. Okay, here we are moving again in the direction of the current, but the current is I1 now. Okay, so I1 into R, I1 into your current, which is 1. So that will be minus, because we are moving in the direction of current. In the direction of current, there is potential drop. Okay. Now come to this battery. In this battery, we are moving from the negative terminal to positive terminal. So plus 3 voltage gain. Okay. And here in the direction of current again, so it will be minus 4 into I. The current over here is I. Okay. And of course is equal to potential at B, which is 0. Okay, potential at A is 16. We have considered it as 16. Now let's write this entire thing in terms of I1 and I2. Here you can see minus 4I will make it minus 8I. Okay, can you hear the straight dogs? Let's wait for a second. Let's continue now. Here we have minus 9 plus 3, that will be minus 6, and here minus I1. Okay, so this is equal to 0. PB is 0. Right, let's write it in terms of I1 and I2 as I was saying. So you can write I as I1 plus I2, because I splits into I1 plus I2, right? Using KVL you can write KCL, sorry, I is equal to I1 plus I2. Okay, so here we'll substitute that. We'll get first of all 16 minus 6, that is 10, and here you'll get minus 8 I1 minus 8 I2, this is plus 10, and what do we have? Minus I1. Okay, so this will give us the equation 9I1 minus 9I1 minus 8I2, and let's take this 10 to the other side, that will be minus 10, so we can cancel this minus sign throughout. Okay, so 9I1 plus 8I2 equals 10. That is our equation 1. We have to solve this loop now. We'll move around this loop and find one more equation, and we'll solve the equation into variable. Okay, you can note till here. Okay, I'll erase this off now. Now let's move in this loop. Let's choose the path A, B, C, D. Okay, let's move from A to B, B to C, C to D, D to A. Okay, so when we go from A to B, it is in the direction of the current, and the current is I2, right? So I2 into 2, I2 into R. Okay, I2 into R, so 2I2, and that will be minus in the direction of the current, potential drop. Now we move from B to C, nothing. C to D, we have this resistance. Okay, and if you see this, R direction is opposite to the direction of the current, right? I1 is in this direction, we are moving in this direction. Okay, so direction is opposite to current, which means plus. So I1 into R, so I1 into 1, that is I1. And here we will move from the negative to the positive terminal. We are moving from C to D, right? So from negative terminal to the positive terminal, potential gain. Okay, so plus 9 over here equal to 0. Now let's solve this. This will give us I1 minus 2I2 is equal to minus 9. So this is our equation 2. Let's solve it with that one, and let's see what we have to find. We have to find I2, right? Current through this 2 ohm resistance. So let's eliminate I1. So we'll multiply 9 over here, 9 I1 minus 18 I2 and minus 81. Okay, now we will subtract this 2, and this will get cancelled. You can easily see 9I1 will get cancelled. This will be added, right? Because we are subtracting this equation from that. Okay, so this will be added. 18 plus 8, that will be 26I2. Now 10 again subtracted, so this will be added to that, minus of minus 81, so plus 81, that will be 91. 81 plus 10, that will be 91. I2 is equal to 91 divided by 26. So I think this cancels by 13. 13 2s are, and 13 7s are. 13 7s are, 7 3s are 21. Yeah. So 7 by 2, 3.5 amperes 3.5 amperes. Option B is the correct choice over here. Okay, so we just used Kirchhoff's law over here, obtained two equations, solved them, and got the answer. Okay, so this whole question was based on KCL and KVL, aka Kirchhoff's law. Okay, over to the next question. So question 13 over here. In this question, you are supposed to find the current through this ammeter. Okay, so not that difficult. Here in this question, we are first going to find out the equivalent resistance, then find out the current in the circuit, then split the current among the resistances and see what is the amount of current passing through the ammeter. Okay, so a simple job to do. Let's do it. So first of all, the equivalent resistance over here, you can see that all of the resistances are in parallel, connected across the same voltage drop, right? So all of them are in parallel. So basically we can write all of this. So R, how many are there? 7, right? So all of them are in parallel. So R by 7. Whenever you have n resistances in parallel, okay, n identical resistances in parallel, okay, the equivalent is R by 7. Okay, this is something that you should know. It is not a thing of rote army as such. Okay, so whenever you have, remember it now if you didn't knew this earlier, that if you have R identical resistances in parallel, the equivalent will be R by n. I'll repeat that. If you have R identical resistances in parallel, the equivalent will be R by n. Okay, here it is 7, right? So 7 are there, so R by 7. So R has a value of 20 ohms, so 20 by 7. Okay, so now let's find the current. The current will be given as voltage divided by R equivalent. So voltage is 2, current is 20 by, the resistance equivalent over here is 20 by 7. So 27 will go on top. So 2 divided by 20, so that gives us 1 by 10, right? So 7 by 10 amperes is the current which is coming out of the battery. Okay, so now we have to split this current and see how much is passing through the ammeter. Okay, so you can see that all the branches have the identical resistances, right? So the current will split equally among them, right? Equal preferences. So this current will split into 7 halves. Okay, so 7 by 10 amperes will split into 7 equal parts. Okay, each resistor will have 1/7 of this current. Okay, I hope you are getting my point. So this current will split into 7 equal parts. This value is 1 by 10 amperes. Okay, so each resistor gets 1/7 of the total current. Okay, and that is 1 by 10. So 1 by 10 passes from here, which is 0.1, 0.1, 0.1. This, if you see, this current will go back to the cell. Okay, it does not contribute to the reading of the ammeter, but here the current which is coming over here, you can see that it will be 0.1 over here, 0.1, here also 0.1, and here also 0.1. This current, however, contributes to the reading of the ammeter, right? So 0.1 plus 0.1 plus 0.1 plus 0.1, that will be 0.4 amperes. Okay, so here we have that in fraction, so 4 by 10, right? 0.4 or 4 by 10. Option C is the correct choice over here. Okay, simple solving over here, nothing much complicated. Let's move to the next question now. So question 14 over here. In this question, you are supposed to find the ratio of the terminal voltage to the EMF of this cell. Okay, now the approach in solving this question may not be that straightforward. Okay, so follow me up. So here, first of all, I can write an equation which relates this two, right? Which relates the terminal voltage with the EMF. So I will write V is equal to E minus I R, right? Where I is the current flowing through the circuit. Okay, so let's find that current first. Okay, then we'll solve this and let's see if we get our answer. So let's find the current in the circuit first. So current in the circuit, I will be given by the EMF, the voltage, divided by the net resistance. Here the two resistances are in series. I hope it is clear. Same current is passing through both, right? So yeah, they are in series, so NR plus R. Okay, the voltage divided by the equivalent resistance over there. So let's substitute this over there. So V is equal to E minus E. Now I'm substituting the value of I over here. Okay, let's substitute this I over here. So I divided by NR plus R into this R. This is I, right? And into R. So you can see that first of all you can take this E common. So you can obtain this ratio over here. Okay. So 1 minus, and you can see that this R can be taken common. Right, this R can be taken common and this can cancel with the R on top. Okay, now we are left with 1 divided by N plus 1 over here. So we want the ratio of V by E, and it will be simply, let's take the LCM, N plus 1. So N plus 1 minus 1, that will be N, right? So N divided by N plus 1 is the ratio of terminal voltage to your EMF of this cell. Okay, so we just use this equation, we found out the current in the circuit, and then hopefully manipulating it, we got our answer. Okay, over to the next question. Question 15 over here. In this question, we have a potentiometer. The initial length of the potentiometer wire is L. We have done an experiment to determine the EMF of a cell. Okay, so in that case, we have obtained a null point at L by 3, 1/3 of this initial length. Now we have increased the length of this potentiometer wire by L by 2. Okay, we have just increased this original length by L by 2. Okay, so you are supposed to tell what will be the null point in this case. When we increase the length of the potentiometer wire, what will be the null point now? Okay, so let's do it. If you have studied potentiometer just for the board's sakes, which is cancelled now, you won't be able to do this question. Okay, it is a conceptual one. You should know a good logic of a potentiometer in order to solve this question. Okay, so using potentiometer principle, we can write that EMF or the voltage drop is directly proportional to length, and we can write E is equal to phi x. Right, voltage drop directly proportional to length. Phi is a constant. Phi is voltage gradient over here. So let's consider the voltage drop across the two ends of the potentiometer wire is V. Okay, the voltage drop, we have connected an external battery of voltage V. Okay, so the voltage drop is V across the two ends. Okay, and in the case 1, this case 1, we can see that this voltage drop will be equal to V by L, right? The voltage divided by the total length. The length in the case 1 is L. Okay, so voltage drop is V. The voltage drop is V across the length L. Okay, now the null point is obtained at L by 3. So from here you obtain the EMF of the cell, right? That was the aim of the experiment, to determine the EMF of the cell. So we now know the EMF of the cell is V by 3, 1/3 of this potential applied. Now let's come to scenario 2. Apply the same formula. Here the potential drop is also E, right? We are balancing the same cell, of course, right? So here the thing that will change is the voltage gradient, and also the balancing length. The length where null point is obtained will also change. Okay, so these things will change in such a way that the product remains the same. Okay, the EMF will be still E, right? We are balancing the same battery, that's what I said. So here in place of E, you can substitute V by 3. Now what will be the new potential drop? You can see that the voltage drop is still V, right, across the length, but the length has increased, right? So voltage drop is still V divided by the length now. What is the length? Length is L plus L by 2. That is 3L by 2. Okay, 3L by 2. Now this will give us X dash. Okay, now solve this and we'll obtain X dash, which is the new balancing length. So V by 3 will get cancelled. So you obtain X dash is equal to L by 2. Okay, so that is our answer. The new null point will be at L by 2. Okay, now instead of doing it step by step, you could have just used phi dash X dash is equal to phi into X. Okay, from here you can see that the EMF of the cell is same. We are balancing the same cell. So phi dash X dash will be equal to 5 phi into x. Okay, so since the voltage, the potential gradient changes in the second case, the length also changes in order to maintain the same product over here. Okay, so you could have just used this phi dash into x dash is equal to phi into x over here. Okay, so that is how you do this question. Let's move to the next question. So question 16 over here, the last question for the day. Then I'll give you your homework question and then we can say a goodbye. Okay, so in this question you are supposed to find the equivalent resistance between A and B. This is a question from 2005. I think it is also an IEEE question. I think it's from IEEE 2002. Okay, also note that it is a question from the moderate category now. Okay, so quickly try it. I'll do it in 3, 2, 1. Okay, so I told you about this in some of the previous question, in one of the previous question that we discussed today, that whenever you don't find two or more resistances in you know it, right? So here you can see the Wheatstone logic, right? Which I mentioned. Here the resistances can't be seen in series and parallel. So we look out for other options. The other options, one among them is the Wheatstone network. Okay. Also, this question can be done by your mirror symmetry, right? It can be done by mirror symmetry as well as folding symmetry. Okay. But anyways, since you are a BITSAT student, I won't insist you to do to go through those methods. Okay, so anyways, we'll do it by the Wheatstone method. You can see that 2R by R is equal to 2R by R, right? R1 by R2 is equal to R3 by R4, right? So the potential over here is same as that over here. Okay, so this resistance is useless, you can disconnect it. No current will flow in this branch. Here also you can see R by 2R is equal to R by 2R. So R1 by R2 is equal to R3 by R4. So here also whatever potential is there over here, same potential will have over here. So you can remove this resistance as well. Okay, no current will flow through there. So you can see now it is very simple, right? 2R in series, 2R in series, R small r in series, and that all of these are in parallel, right? Now the combination is so simple. So simply 2R plus 2R, that will be 4R. Wait, 2R plus 2R, 4R. 2R plus 2R, 4R. 4R in parallel, that will give you 2R. Okay, so 2R, 4R, 2R, 4R. 4R in parallel gives you 2R. Okay, so finally we have 2R and this 2R, right? R plus R, 2 small r. Okay, so we have 2 big R and 2 small r. So we have to find the equivalent now. Again, product upon sum now. So product 2R into 2R upon sum 2R plus 2R. Okay, so that will be 4R divided by, I can take this 2 common, 2R plus R. Okay, this is our R equivalent. This and this will get cancelled. 2R upon R plus R. 2R upon R plus R. Option A is the correct choice over here. 2R upon R plus R. Okay, so that is how you do it. You should have just looked out for the balanced Wheatstone network over here. Okay, of course you can do it by the symmetry logics. Anyways, we'll move to your homework question now. Okay, so question 17 over here, this is your homework question. Okay, written in words like a question should be. So I'll definitely rate it in the moderate category. You can pause and take a screenshot if you wish to try it later. Okay, so that's all for today's class. I hope you enjoyed it. If 2 plus 2 is equal to 4, then smash like, subscribe. Keep enjoying physics.